In this lecture, we're going to look at exercise endocrinology, so specifically how the endocrine system or our hormones are affected by exercise and some of the responses to training, which really dictates some of our program design, because it's ultimately building muscle that is partly about the hormonal response that we get, or not only building muscle, but getting leaner, getting bigger, getting faster, getting stronger. So our hormonal responses to resistance training, I think this slide sums it up quite nicely, because if you look at the barbell over on the right, there are certain mechanical forces that are imposed upon the muscle and our exercise stimulus, such as the volume, the sets times the reps, also the intensity and our rest periods. They will dictate the glands of what is secreted from the glands of the endocrine system. So that's the classic endocrine response that goes through the bloodstream, things like growth hormone and testosterone, and they bind onto the receptors on the cell, as we can see the large cell over on the left, and they get inside, the steroid hormones get inside and influence our DNA and change the response of the cell. So this can happen inside muscle cells and other cells to determine cell breakdown or cell growth. But there are also other more indirect and less known effects of the endocrine system. So we have paracrine hormone release, which you can see down in the bottom in the blue flattened disc, and that's when a hormone is released inside of a cell, so not the endocrine system classically. It's released inside of a cell and it goes into the bloodstream and has an effect on other cells or target tissues in the body. And then lastly, we have autocrine release, and that is when the mechanical forces imposed on a muscle trigger a release of certain hormones inside of the cell to take an effect actually inside the same cell. So we can see there are different effects and different ways that resistance training or other forms of training can actually affect the cells of our body. And remember that a lot of it is about the number and the quality of receptors that are around. It's not just about the amount of hormone that's in the bloodstream. It actually has to get inside the cell to have an effect. So here is just a reminder of the hormones of the pituitary gland, and we looked at this in depth earlier in the cert, so we'll just take some specific ones and look at their effects during exercise. So the first one I want to look at is what's called antidiuretic hormone. So this is the hormone that is responsible for the balance of water in our body. So when we exercise, obviously we sweat, and that causes a loss of blood plasma. So the actual volume of blood decreases because the plasma is reduced. So we get what's called hemoconcentration. So the amount of hemoglobin inside of our blood actually increases, or the concentration of it increases. The result of that is increased blood osmolarity. So this stimulates osmoreceptors in our hypothalamus in the brain, and that stimulates the posterior pituitary gland to release antidiuretic hormone. So that's the cause and effect. So there's an effect from sweating that has a response that triggers a reaction in the brain. The brain releases antidiuretic hormone. It reacts in the kidneys, or has an effect on the kidneys, and the kidneys reabsorb, so they try to suck up as much water and reclaim as much water as is possible. And then what happens is our plasma volume decreases. So that is how our plasma volume will increase. So that is how that our body compensates for exercise. And then after exercise, obviously, we drink water, and that helps to restore, particularly if we take some electrolytes. And we can, so that's why it's important to consume some fluids, and particularly with the right electrolytes when we're doing prolonged endurance exercise. So growth hormone, we mentioned previously, is secreted by the pituitary gland, and it promotes muscle growth and hypertrophy by affecting amino acid transport and protein synthesis. And it has effects on the liver and stimulates insulin-like growth factor. So that helps to stimulate fat burning. It helps to spur glucose for later in exercise. And when we are doing aerobic exercise, levels of growth hormone are increased in proportion to exercise intensity. So also with resistance training, we want heavy resistance, we want a high total amount of work, and we want short rest periods. The reason why we want this is because lactate or lactic acid, which is produced by this type of training, actually triggers growth hormone release. So if we want growth hormone, we have to try and accumulate some lactic acid. So that's why the intense intermittent aerobic stuff or the heavy resistance short rest period stuff is good in terms of getting that response. So post-exercise, how we can increase the amount of growth hormone the body has produced is by consuming carbohydrate and protein. And there's now research to show that if we consume carbohydrate and protein just before exercise, that will stimulate more growth hormone. Now we have to balance that with not having gastric upset during exercise. So tends to be generally okay with resistance training, but when we do intense training, and particularly anaerobic training, we tend to get a little bit of gastric upset. So there's a little bit of a trade-off there. And our growth hormone will increase gradually. And actually during the night when we're sleeping, that is when growth hormone tends to peak. Let's go and recap on hormones of the adrenal medulla, so the inside of the adrenal glands. So we have the catecholamines, adrenaline and noradrenaline, classically in scientific terms known as epinephrine and norepinephrine. And they both work together to stimulate the duration and force of contraction. And they have a very quick response to strenuous exercise. They help the body to cope with strenuous exercise. So they also augment other hormones or the secretion of other hormones such as testosterone. So when we're producing catecholamines, we get more of a testosterone response. And the metabolic changes that are induced by these hormones generally peak about 30 seconds after adrenal stimulation. So it's very, very fast acting hormones, and the response tends to last for several minutes. So what type of workouts we want to stimulate that is high intensity, high volume workout with short rest that produces the prolonged catecholamine response. So a classical bodybuilding workout or high intensity interval cardiovascular training. Now the key thing, if we're going to be producing a lot of these hormones and really working the adrenal glands quite hard, is that we need adequate rest for the adrenals to recover. Otherwise, the adrenals move to producing chronic levels of cortisol, which we'll see later on is bad for us in terms of our gains normally associated with being in the gym. So here we can see pictographically the catecholamine response to exercises, and you can see norepinephrine and epinephrine. So you can see on the left, when we're talking about as a percentage of VO2 max or aerobic exercise intensity, classically this is how these things are measured, we can see the higher intensity, above 75% of it, really gives very quick responses in both of these hormones. And we can also see in terms of the duration of exercise, how they're also affected, and as we go on with exercise, they increase their levels and then they reduce very quickly after exercise. This is one of the key mechanisms by which exercise can reduce the amount of stress or what we call state anxiety that we actually feel. Because although we get a response, an initial response of stress hormones, it's in a way that the body can control, and then we get a dramatic reduction after exercise. So reminding ourselves again of the pancreas, we have insulin which is released when we've got too much blood glucose, and we've got glucagon when we've got too little blood glucose. So how do they respond to training? Well, here we can see there are differences in the top graph between trained people and untrained people. So we're looking here at glucose response. And we can see that when somebody is trained, that they tend to have pretty steady levels of glucose throughout exercise, which means that they can exercise at quite a good intensity throughout. Whereas we see with untrained people that it drops off very, very significantly. So as we become more trained, we get a training response in terms of these hormones. So we looked at the bottom left in terms of plasma insulin. So we can see again, there is a difference between trained and untrained people, and the trained people tend to have different fluctuations in insulin. And then we can see also with plasma glucagon on the right-hand side, there are very big differences in trained and untrained people. The trained guys don't need to release as much of this as untrained people. So there's definitely a difference, and there's a compensatory effect on these hormones of training. So let's talk about increasing glucose metabolism, because it's very important, particularly if we're talking about endurance exercise. So the hormones that will act to increase our glucose metabolism are glucagon, also adrenaline or epinephrine, noradrenaline or norepinephrine, and also cortisol. So what happens is that glucagon, adrenaline, and noradrenaline and cortisol, they all help to promote both glycogenolysis and gluconeogenesis, which are ways of kind of breaking down glucose from the liver and muscle, and also converting fats and amino acid into glucose within the liver. That means that we have a nice steady supply of glucose that helps us to exercise at higher intensities for longer. So insulin also helps to take that glucose and transport it to the muscle where we can actually use it. So as we know, our glucose levels will decline as we do prolonged exercise, and that indicates that exercise actually facilitates insulin action so that there's less required during exercise than at rest. So we can see that exercise really has an effect here. Here we have a look graphically and both at cycling at 65 to 70% of aerobic capacity, and also of sprinting, and we can see the blood glucose and insulin responses here. So on the left, it's purely blood glucose. So we can see that when we sprint, we have very quick responses in blood glucose. The body mobilizes glucose very quickly, and then after sprinting, it drops off. So it's a very immediate response. And then we can see that at a lower intensity of exercise, that our insulin initially spikes very, very quickly, and then the insulin drops off, and the glucose then starts to rise initially for about 30 minutes into endurance exercise, and then it sort of levels off and gradually decreases as we go throughout our exercise. So let's look at cycling, and a lot of these studies are done on cycling because we can measure it very well in a laboratory. We can measure the intensity. We can stick catheters and things in to take blood out and measure VO2 max. So that's typically why more of the studies are done in terms of cycling in a lab than they are on resistance training. But we can still gain some insights that we can apply across the board. So here we look at a number of hormones. So we can see that there's a very complex and coordinated hormonal response to exercise. So let's just take a couple of them. We can see that glucagon is released very quickly, and epinephrine and norepinephrine are released very quickly, and they continue to rise throughout exercise. We can see that cortisol, which is in this sort of brown with the inverted triangle, it takes around 15 minutes before it is actually released, and then it will spike very, very quickly for about another 15 minutes. Then it will drop off, and what we don't see here is that growth hormone will then kick in its place to help to stimulate glucose. So we can see there's a very coordinated response from a range of hormones, and the result we can see along the bottom in the blue with the X's is that glucose levels tend to stay reasonably level, and enabling a good supply of energy to the muscles throughout exercise. So a lot of complex endocrine responses going on behind the scenes that we never even think of. So let's now talk about fat metabolism, because it's very significant or an important goal for many of our people. So how do we get fat metabolism through an endocrine response? Well, cortisol will increase fat metabolism, as will growth hormone, and as will the catecholamines, adrenaline and noradrenaline. So what actually happens is that cortisol initially will accelerate lipolysis. So it breaks down fat and releases what we call free fatty acids into the blood so that they can be taken up by the cells and used for energy production. So particularly when we exercise at lower intensities, more of the energy will come from free fatty acids. But some people think that intense exercise is all about glucose and lower intensity exercise is all about free fatty acids. In effect, there is all energy systems are combined to produce energy. So we have some from glucose and some from free fatty acids, some from ATP, CP system, and it's the exercise intensity that dictates which one actually predominates. But for exercise that's longer than 15, 20 seconds, we're talking about glucose and free fatty acids predominantly, and they vary depending on intensity and duration. So the levels of fat metabolism, our cortisol peaks and then returns to near normal levels during prolonged exercise. So there's an early peak, as we've seen a few slides ago, and then it reduces during prolonged exercise. And then the catecholamines and growth hormone take over to take away the responsibility from cortisol of releasing free fatty acids in the bloodstream. So we can see there's a nice coordinated response between cortisol, growth hormone, adrenaline, and noradrenaline to give us free fatty acids and enable us to exercise at lower intensities, or indeed contribute to energy production at higher intensity. So looking at the hormonal and free fatty acid responses to cycling at 65 to 75% of VO2 max. So there's quite a significant contribution from free fatty acid at this exercise intensity in trained individuals. So we can see on the left-hand side, cortisol, after about 15 minutes, cortisol will kick in and increase rapidly. Then it's going to drop off, and we can see that free fatty acids continue to increase throughout the duration of exercise. And on the right-hand side, we can see that epinephrine, norepinephrine, and growth hormone, later on growth hormone, will all kick in to help to mobilize free fatty acids and to contribute to energy production during prolonged exercise. Let's now talk about testosterone, and we covered that in detail early in the certification, but just as a reminder, it's a steroid hormone that's secreted mainly by the testes, but also by the adrenal glands in smaller amounts. Men obviously have much more testosterone than women, which gives us bigger muscles, and it's an important anabolic hormone. So it has direct effects, and it also has indirect effects through its production of our triggering of growth hormone stimulation. So how do we increase testosterone through training? Well, the training time and volume are absolutely key when we're talking about testosterone production. We want exercises that have large muscle groups, for instance, squats, deadlifts, and power cleans if we're talking about traditional exercises. So we want to be using lots of muscle mass. We also want high intensity exercises, typically 85 to 90% of one repetition maximum. So really pretty significant weights. We also want a moderate to high volume of exercise and short rest intervals. Now clearly these responses are things that if we're looking for all of those things, we need to be in quite a high training state. So we have to build up to that training state. So we then tend to need a training maturity of a significant amount of period before we can really exercise at this level with these amount of variables being quite high. And this sort of training can increase testosterone in males by about 30% during maximal work. So there is not really the evidence that there's similar increases in women, because obviously they don't produce as much testosterone. They're only relying on the adrenals to produce it, but there is a small impact because women obviously do put on some muscle. So let's now talk about anabolic steroids and why people take anabolic steroids, because it's something that is still very predominant. Although they're illegal, it is predominant in many countries. What they do is they mimic the effects of testosterone, so they have muscle building effects, and there's a whole range of anabolic steroids, and it's too big a topic to go into in detail, but they were originally created and designed for muscle wasting diseases, and they were very effective, which is why the bodybuilding fraternity got the hold of them and started to apply them for resistance training gains. And they've been used in competition for decades. What they do is they increase protein synthesis, so they build mass, but they also enhance recovery. So they reduce the muscle breakdown, and they mean that people can train harder and longer and thus get a greater training response. They also have the effect of increasing arousal, aggression, and mental focus. So they have those sorts of effects in the gym, in that they will increase motivation to exercise and the intensity at which somebody can exercise through mental effects. And how they're taken is they're either injected, or very often they're taken orally as well. And often they're what we call stacked. So we have different ones that are added on top of each other ones, and there are very complex cycles of people using large amounts and then dropping off and other ones kicking in. So there's this whole cyclical and stacking effect that goes on. And the end result is that they increase muscle mass and strength, but they do not have an effect on aerobic power. So only useful in terms of the sort of gym or the strength-based things like bodybuilding. So there are obviously very significant effects of anabolic steroids, and really go and Google Eastern female athletes, and you'll see some really hard-hitting videos on what happens with females whenever they take them, but with males as well. There's a numerous amounts of effects. So with physical, in a more cosmetic side effect is they get acne, premature baldness, and it's not the only reason that induces baldness, by the way, but also they get breast enlargement, known as gynecomastia. And they also have masculinization in females. So females who take anabolic steroids tend to develop a very deep, gruff voice. They develop facial and body hair, which clearly isn't that attractive to most people. They also can increase tendon rupture. So that's one of the dangers that often people who are on anabolic steroids, you'll hear of them ripping a bicep off the bone or ripping a pec, because the muscle mass or the muscle strength increases dramatically, and the tendon strength doesn't increase as quickly. So that the muscle can generate more force than the tendon can handle. So therefore the tendon ruptures or actually pulls off the bone. Psychological effects would be increased aggressiveness. So the term is known as roid rage that people get with that. And it's not always the case, but very often. There's also reproductive effects where they can contribute to shrinking of the testes, a reduced libido or sex drive, reduced sperm and therefore fertility, and then we can also then have impotence. So there's varying effects in terms of the reproductive. And in females, they cause enlargement of the clitoris. There's also very, very significant cardiovascular effects. So the HDL to LDL ratio changes. So you get a lot more low-density lipoprotein, which we all know is the dangerous form of cholesterol. We also get an impaired glucose tolerance, so it predisposes people to diabetes. We get hypertension, also stroke and heart disease. And within the liver, people can often develop tumors and cysts and jaundice and end up with liver failure or often liver cancer as well. So very significant effects from testosterone, from taking anabolic steroids. So hopefully here we can see that the endocrine system contributes very significantly in many, many ways to our training responses. And by manipulating our training and our program design variables, we can actually start to control the endocrine response to help our clients to ultimately achieve their goals.